Welcome to this explainer. Today, we're jumping straight into something so fundamental, we literally use it every single day without a second thought. We're diving into the incredible historical struggle of how humans learned to quantify their world and how they transformed the mundane digits 0 through 9 into a true masterpiece of human innovation.
To really grasp this, picture this. You and I are way back in the Stone Age. We've got a herd of cows, the sun is going down, and we need to know if every single cow has made it back safely from grazing. But here's the catch, we have to do this without using any of the numbers we know today. No counting out loud, no written digits. So, how do we solve this?
Well, the earliest and most basic fix was what we call a one-to-one mapping. Basically, early humans would just grab a physical stick or maybe a pebble for every single cow. One cow walks past, you put down one stick. When they come back, you just match them up again. If you've got sticks left over, you know you're missing a cow. It's super logical, right? But it definitely has a massive limitation.
Section 1. The urge to count and early mechanisms.
Okay, so obviously, you can't lug around a whole forest of sticks just to count a massive herd. Our ancestors needed a more permanent, lightweight solution. Enter the tally mark. Instead of carrying the physical objects, early humans started etching marks directly onto surfaces. There's this amazing archaeological find called the Limpopo bone from South Africa. It's roughly 44,000 years old, features 29 notches, and researchers think it might have actually been an early lunar calendar. Then you have the Ishango bone from the Democratic Republic of Congo, dating back 20,000 to 35,000 years. Instead of carrying sticks, they were carrying the data itself.
But as settlements grew, so did the sheer volume of stuff people had to track. They started experimenting with other inventive methods. For instance, assigning a specific alphabet letter to an item, like A for 1, B for 2, and so on. But you probably see the issue here. You hit a brick wall the second you get to 27 objects. You just literally run out of letters.
Section 2. The limits of perception.
Now, the real issue with just stacking up endless tally marks actually comes down to our own biology. Human beings struggle to instantly recognize groups larger than 4 or 5 at a glance unless we're actively pointing and counting. To get around this, indigenous groups across the globe came up with some brilliant workarounds. Take the Gomolgo people in Australia, for example. They solved this visual overload by counting in groups of 2s. 1 is Urapan, 2 is Ukasar, and 3 is just Ukasar Urapan. They basically stacked these building blocks, calling any number greater than 6 a Ras.
And this concept, grouping things together, was a real game changer. It popped up completely independently all over the world. From indigenous tribes in South America to the Bushmen in South Africa, humans just naturally started clustering numbers to make them digestible. This directly led to base counting sizes of 2, 5, 10, and 20.
Section 3. The Roman numeral system.
This vital idea of grouping ultimately paved the way for one of history's most famous methods, which popped up in Rome around the 8th century BCE. Rather than carving out 50 individual tally marks, the Romans created landmark numbers to condense those large groups into a single symbol. You know the ones, an I for 1, a V for 5, an X for 10, and L for 50. It was a highly structured way to visually compress all that data.
But let's be real for a second about actually using this system. If you wanted to write a number like 2,367, you still ended up with this massive clunky string of letters. MM, CC, X, L, XI. Sure, it beats carving 2,000 notches into a bone, but it was still incredibly bulky.
And here's the real kicker. This system was an absolute nightmare for complex arithmetic. I mean, just imagine trying to multiply or divide those long strings of Roman letters. It's a mess. This created massive friction as trade, engineering, and scientific needs began rapidly expanding around the globe.
Section 4. The Indian Number Revolution.
We desperately needed a better way. And the ultimate masterpiece, the system that finally solved our ancient counting problems, emerged in India around 2,000 years ago. Actually, the conceptual foundation was laid way before the physical symbols were even standardized. Ancient Indian texts, like the Ʌʌjveda Samhita, were already naming numbers based on powers of 10. They had these beautifully distinct, logical words for 10, 100, 1,000, stretching incredibly all the way up to 1 trillion. The mental architecture for modern math was already completely in place.
As for the physical evidence of this revolution, there's a fascinating artifact from the 3rd century known as the Bakhshali manuscript. It shows the very first known written use of 10 specific digits. But the absolute biggest breakthrough here is that it includes a distinct dot used to represent 0. Conceptualizing 0 as an actual number and a placeholder was the ultimate key that unlocked modern calculation.
Fast forward to the year 499 CE, and the brilliant mathematician 𒁹𒁹𒁹𒁹 was fully exploiting this incredibly efficient place value system. Because a digit's value changed based on its position, and because 0 could hold those empty columns, 𒁹𒁹𒁹🐬 could perform these elaborate scientific and astronomical computations that the Roman numeral system simply could never, ever handle.
Over the centuries, the physical shapes of these 10 symbols morphed. They started out as ancient Brahmi scripts, branched out across different regions, and gradually evolved into the exact numbers we type on our keyboards today. It is such a beautiful visual history of a truly global idea. And man, did this idea build momentum quickly. Around 800 CE, this revolutionary Indian system was transmitted to the Arab world. By 825 CE, it was heavily popularized by the Persian mathematician al-Khwarizmi. Fun fact, his name is actually where we get the word algorithm. By 1200 CE, Fibonacci was practically begging Europe to adopt these numerals. But Roman numerals were so deeply ingrained that it took all the way until the European Renaissance, in the 17th century, for Indian numerals to completely take over.
Now, quick historical footnote here. Because Europeans learned the system from Arab scholars, they mistakenly called them Arabic numerals, but the Arab scholars themselves actually called them Hindu numerals. Today, textbooks and historical documents are actively correcting this terminology to Hindu numerals or Indian numerals to properly honor their true geographic origin.
To wrap up our explainer today, I want to leave you with a profound thought from the legendary mathematician Pierre-Simon Laplace, who praised the absolute ingenuity of this 10-symbol system. It really makes you wonder, right? How often do we check our phones, glance at our bank accounts, or quickly jot down a date, completely taking for granted the simple digits that entirely unlocked human scientific progress? It's definitely a question worth pondering the next time you count to 10. Thanks for learning with me today.